whole show on the road here. We'll start with some questions from homework. Up to this point, I've assigned up to 98. You guys got any questions for me at this point? Yeah, Lucas. Sure. So 96 says, evaluate the logarithmic expression using your calculator and the change of base formula. So I'll just fire up my old calculator. So here I would do any log of 259 divided by any log of 12. So I'm just going to use the regular old log button on my calculator. So just do log 259 divided by log 12 and press enter. And that decimal is my answer. So 93 through 98, piece of cake, right? Just have to remember what that change of base formula is. And just log of the argument divided by log of the base. Which is not too bad.
Mr. Kulik,
Mm-hmm.
what are your thoughts on not having a test on this chapter since it would probably fall during AP week?
I mean, we're going to have a test on this chapter, but we can negotiate as the date so that it feels less overwhelming to you guys. How's that? Not nothing. Right? It ain't nothing. I don't know that we'll have a test next week, to be honest with you.
We have APs next week.
I don't think we'd have the test next week. I don't think we'd be finished with the stuff.
Okay, and then there's more APs the week after.
I know, but there's less junior APs the week after.
Yeah. Just like AP Gov, right? AP Comp. AP Gov's next week, AP Comp's the week after.
Yeah. So the comp's the one that I have to work around, but that's fine.
Okay.
Not a big deal. We'll figure it out.
Or you could just not give a test.
I mean, what are we going to do with the chapter then?
It's not on the final level. And we have 200 problems to do for homework.
Yeah, well,
That is a lot.
I just feel
98 math problem.
Oh, no, 134.
That's wild.
it goes for a while. There's a lot of problems. Hey, look at me. I understand. It'll be okay. Has Mr. Kulik ever once cared about anybody's late work?
No.
No.
No. So say thank you
Thanks, Mr. Kulik.
and just relax. It'll be okay. Like, I get it.
Yes.
You know what the next class's plan is?
What?
Homework quiz and Delta Math. So like it's a big here let us jog in place for a minute.
Okay.
Let everybody kind of get caught up a little bit. You know. We'll keep on inching our way forward after that, but
Yeah, that's good.
you know, we only meet twice next week. Right? One day is us just doing work in class. The other day, we'll go a little bit further, but we don't have to go tremendously far. That's one AP week done. You know, like, honestly, the week after, I'm not sure we'll finish and have a review day and have time to do the test the week after. I don't know that will be a test the week after, even, to be honest with you, looking at what's left to do.
And then review for the rest of the year for a final.
It didn't even do much for
No, man, I'll cook up something else for us to do. Look, it's okay, guys.
No, it's not, Mr. Kulik.
I just don't have.
Hey, I know the seniors are leaving, but you guys have like
There's 2
6 weeks left.
No, we don't.
You have all of May and then 2 weeks in June.
5 weeks.
Okay, I'm gonna call that 6 weeks since it's 6
No,
weeks.
we have like a month. We have a month left.
You have like 20 school days, but you have like 6 more weeks that you have to keep getting up for school.
Don't remind me.
I think
Okay.
it's
You
Yeah,
have,
but we actually
there's
have some,
there's
we have,
2
we have,
exam
no,
days
Mr.
the next
Cook, we
week.
have-
That's a
we
6th
have-
week.
We have 4.5. Memorial Day weekend.
I know.
3 days off for
Look,
that.
I understand. I'm not arguing with you. But there's like 6 more weeks that you have school days during those weeks
4.5
of days.
until exams.
Right. Those exams are still days you have to go to school, right?
Well, like, you don't
Not necessarily.
Okay. Fair enough. Anyways, you still got a long time. Quit looking at the finish line. You can drive yourself crazy. Just worry about today. And then maybe a little bit about tomorrow. And not what's happening, June 13th or whatever the last day of school is. Okay? You know what I'm saying? Like, I'm not trying to be a jerk about it. I'm just trying to give you, like, helpful life advice. Because it feels like there's a ton of stuff to do still. And, like, you just don't want to do it because the weather's starting to get nice and, like, the seniors are gone and they're leaving and they're done. And, like, I wish I was done. Can I just be done? No. Next year you can be at this time, which will be great. But we're not seniors yet, And we're going to keep going. We're going to keep doing stuff. Part of it is, I know that we had kind of a bad Algebra 2 experience.
Oh, yeah.
And I want to keep doing stuff, even if it's recircling and getting back to doing some ideas from Algebra 2 that I know you didn't get to, that I think are important that you've seen before you take an ACT again or another math class or whatever. And it's not because I'm trying to punish you or work you to death. That's honestly not what it is. But I want us to do a good job so we can go to our next class that we're not like feel hopeless and clueless and you know what I mean? All right. Yes, everybody's mad at me. That's okay. You guys can be mad at me.
We're not mad, don't worry.
I mean, it sounded a little mad, but that's okay. I get it. I was mad a lot when I was a student too. It's okay. So we were doing questions. Does anybody else have some homework questions that we want to talk about? No. Okay. Fair enough. If you change your minds, you can always hit me up next time or whatever. Happy to do these. Today, what we're going to be talking about is we're going to start 15.4. And we're going to be solving exponential and logarithmic equations. So we're just going to do some examples of problems. We're going to talk through the technique or techniques that you can use to do these kinds of problems. And then that'll be that. Okay? So I have I think 5 or 6 examples that I kind of want to talk through. And that's all I have planned for today. Okay? So let's take a look at this first example. 14 times 1/3 to the x minus 1 is equal to 126. So if I am looking to, I recognize this is an exponential equation. How do I recognize that? The variable is in the exponent. Right? Everybody recognize that? Okay. To solve any exponential equation, I need to get the base of the exponential by itself. So my first order of business is to get rid of that 14. What can I do to both sides of this equation to get rid of that 14? What? Divide by 14, right? Everybody's okay? $126 divided by 14 is 9. And now, one way I could solve this is if I can make the bases match on both sides of the equation, I can just set the exponents equal to each other and solve. So what I'm going to try to do here, or one way I can try to do this problem, is to try to rewrite the 9 so that it is base 1/3. So it's 1/3 to some power. So the first thing I would do is try to get it to be a fraction. So I know that if I use a negative exponent, that makes a reciprocal. So if I do both of them at the same time, that's doing nothing at all, right? Is that okay with everybody? And then I recognize that 1/9 is the same thing as 1/3 squared. Is everybody okay with that? And then how do I simplify if I have an exponent of an exponent? Right? Like I have something squared to the -1. What's the rule on how to deal with that? So let's go back and just kind of do an easier example. If I have x squared to the 3rd, that's x squared times x squared times x squared, right? So that's x to the 6th. So what's the relationship between 2 cubed and the 6th? The exponents were multiplied. So I'm going to do the same thing here. So that's going to be 1/3 to the -2. And now that the bases of the exponent are the same, I can ignore them and just set the exponents equal to each other and solve for x. We okay with what I did there? Now there's an alternate approach that we could have taken. Yes, of course. Uh-huh. Okay. So starting over, I would do the same first step of getting the exponential by itself. And now what I would want to try to do here, rather than trying to make both sides have the same exponential base, is I would think about what can I do to both sides to cancel out the exponent base of 1/3. What operation cancels out an exponential? We've just been learning about them. Starts with an L. A logarithm. Great. Which kind of logarithm do I want to do to both sides? What base do I need my logarithm to have if I want to cancel out exponent base 1/3? It's really obvious. It should be 1/3 also. So I'm just going to use the exact same base. Everybody's okay? So the base of my logarithm should match the base of my exponential. So I do that. Now, as we had established in the previous lesson, log base 1/3 cancels exponent base 1/3. So left on the left-hand side with just x minus 1. I can then just add 1 to both sides. And now it's just a calculator problem. So if I go to my calculator, I would do 1 plus, and then I'll press math, scroll down to the bottom to choose log base. I can edit in the 1/3 for the base of my logarithm and type in the 9, press enter, and there's the -1 that we saw from before. Now, of these two methods, which one is going to be the more versatile of the two? The second one. Very good. Why? Imagine if this number was like 8. Would it be really easy to write 8 as an exponent with base 1/3? No, man. There's not a real obvious way to do that. You can do it, but it's like, it's gross. And it just involves logarithms again, right? So that more versatile method is that second method. Both of them are acceptable. Both of them are correct. But that second method, I think, is just a tad more versatile. Let's do another example. So I have 12 times 3/2 to the x over 5 equals 27. First thing I'd want to do is divide by 12, right? So I divide both sides by 12. I notice that 27 divided by 12 can reduce. They both contain a factor of 3. So that will reduce to 9/4. If I think about this as trying to write these with the same exponent base, what's the relationship between 9/4 and 3/2? Squared, yeah. So I can just write 9/4 as 3/2 squared. Since the base of the exponentials are the same, I can just set the exponents equal to one another. And if I multiply both sides by 5, I get x equals 10. Alternatively, I could have also used a logarithm. So if I wanted to cancel out the exponent base of 3/2, which logarithm would I use? Log base 3/2. Yeah. Log base 3/2 cancels exponent base 3/2. If I multiply both sides by 5, God bless, I'd have 5 times log base 3/2 of 9/4. I can just type that into my calculator. 5 times, math, and then pick the log base command, and then just type this in exactly like it looks like on my sheet of paper. And once again, I get the exact same value, 10. How are we feeling so far? This is okay? It's not so bad, right? Let's look at the hardest version that I'll give you guys to work on of this kind of a problem. So if I look at this example, what's different about this example than all the previous ones we've looked at? Zach, what's that? I have 2 x's. Very good. That's going to make this problem considerably more intricate to solve. But we're just kind of go through this one step at a time. The first thing I would do is let's get rid of the fraction part, right? Nobody likes fractions. Let's get rid of that. How am I going to get rid of the divides by 4? Just multiply both sides by 4, right? Okay. My next order of business would be to get rid of the 3 to the negative x. I want to get rid of that negative exponent on it. How do I get rid of a negative exponent? What? Okay, so you can write that as a reciprocal, sure. Like that, right? Now we've generated a fraction, but that's okay. Let's just get rid of that fraction. What would I have to multiply to get rid of that fraction? 3 over x, or 3 to the x, excuse me. Right, so I do that to both sides. When I multiply here, 3 to the x times 3 to the x is like 3 to the x squared. Now I can simplify that, but I'm going to leave it that way for the time being. And then 3 to the x times 8, because the bases are different and the exponents are different, there's no simplifying that I can do with that. It is what it is. Everybody okay? So far, so good? Now, if you look at this and kind of squint, this looks like another kind of problem that we've solved in this class and in previous classes. What other kind of problem does this sort of look like? Anybody want to take a guess? What other kind of problem does this sort of look like? Let me give you a hint. Okay. So I have something squared, and then a constant. A what? A polynomial. Specifically, what kind of polynomial? A quadratic. So what I'm going to do is just say that, oops. I'm going to replace all my 3 to the x's with just a new variable that I'm going to call y. So instead of this looking kind of like a quadratic, it is a quadratic. Everybody's okay there? To solve a quadratic, what do I need to do? Got to get it all onto one side. And now that it's equal to 0, I can either factor or use the quadratic formula, right? If I were to try to factor this, I would need to find 2 numbers that multiply to give us positive 1 and add to give us negative 8. Do you know any 2 numbers that do that? Me neither. So what should I do? Quadratic formula. So that's going to be y equals negative b plus or minus the square root of b squared minus 4 times a times c over 4 times a. I'm sorry, 2 times a. Negative 8 is 8. Negative 8 squared is 64, minus 4 is the square root of 60. And I'm going to simplify the square root of 60. I notice that 60 is 4 times 15. And that's nice because the square root of 4 is just 2. And then I can reduce this to just 4 plus or minus the square root of 15. But I'm not done. Because what did I solve for here? What variable did I solve for? I solved for y. And what does y really equal? 3 to the x. So let's plug that back in. So put the 3 to the x back in. So that's equal to 4 plus the square root of 15. Or we have it equal to 4 minus square root 15. Are we okay still? Okay, to solve this equation, I got to get rid of that exponent base of 3. What do I need to do to both sides to cancel that exponent base 3? What can we do to both sides of this equation to cancel the exponent base 3? What? Log base 3. Excellent. Yes. Oops. That's right, the 3 there. Okay. Log base 3 cancels exponent base 3. So x is equal to log base 3 of 4 plus the square root of 15. Or x is equal to log base 3, 4 minus the square root of 15. So that's just a calculator problem. So math, log base 3, then I'll have plus square root 15. So I got 187 and some change. And then I'll just second and enter and update that to be the minus, and I got negative 187 and change. That's the worst case scenario for solving an exponential, is when it really just kind of turns into this quadratic with an exponential nested inside of it. So you solve the quadratic first, and then you solve the exponentials after. Is that okay with you guys? Let's look at some logarithmic examples. Oh, what did we do? Okay. So here, this is a logarithmic equation. I can tell that because where is the x located? inside of a logarithm, right? We good? Okay. So the first order of business I want to do is get the logarithm by itself. So to do that, what should I do to both sides? Divide by 3. Now, to cancel a logarithm, what do I need to do to both sides to cancel a logarithm? I need to use an exponent base, right? If a logarithm cancels an exponent base, then the exponent base will cancel a logarithm. So if I look at this logarithm, what is the base of this logarithm? I don't see anything written there. What did we have to remember that is? 10. Good. So what exponent base do I want to do to both sides to cancel this logarithm? 10. They need to match. So I like to, when I'm doing this in my notes or whatever, I like to write it really big, so I don't confuse this with multiplying both sides by 10. What I have is 10 to the power of the left-hand side equals 10 to the power right-hand side. So exponent base 10 cancels log base 10, and I'm left with x squared is equal to 100. We square root both sides, and we get x is equal to plus or minus 10. But we're not done yet. Unlike exponential equations, logarithmic equations can have an extraneous solution. So before I consider myself finished, I need to plug these answers back in and make sure that they don't give me either a negative or a 0 inside of my logarithm. So I'm going to be taking positive 10 and plugging it into x squared. Well, 10 squared is 100. That's not 0 or negative, so that one's fine. I'll then do the same thing with negative 10. Negative 10 squared is positive 100. That's not negative or 0. Both those answers are fine. I'll keep them both. All right. One more logarithmic equation example, and I'm done with you guys for today. This will be like the worst case scenario solving logarithmic equations example. That symbol in front of the parentheses in each of those cases is an ln. Remind me again, what does ln mean? That abbreviation is for the natural log, which is log base e. Remember that number e, like that 2.6, whatever, yada, 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 or 7, I don't remember anymore. So that's log base e. So I notice here, distinctly different from the previous equation, I have x's in multiple locations, right? So what do you think should be my first order of business here? Well, my goal is eventually going to be to cancel out these logarithms, right? But to do that, I need the logarithm around the entire left-hand side, and then the logarithm around the entire right-hand side. And right now I have on the left-hand side 2 separate logarithms, and on the left-hand side I have a 2 that's outside of my logarithm. So before I can cancel those logarithms, I got to combine some stuff together somehow. That's going to be my first order of business. So if I look at the left-hand side, how can I combine the natural log of 3x minus 2 with the natural log of x minus 1? You'd think back to last lesson. So what I'd want to do is I'd want to do condensing. So if I use the product property, since they're being added, that would allow me to rewrite this as natural log of 3x minus 2 times x minus 1. Remember doing that last time? On the right-hand side, we'll do the same thing. Again, we'll condense, but this time, instead of using the product property, we're going to be using the power property. That allow me to rewrite that as the natural log of x squared. Do you guys remember doing that last time as well? Now that I have the entire left-hand side inside of a logarithm and the entire right-hand side inside of a logarithm, I can now cancel the logarithms. What exponent base should I do to both sides to cancel the natural log? E is correct. So I'll do exponent base e to both sides. So I'm going to FOIL out 3x minus 2 times x minus 1 at the same time as me rewriting it. Is everybody okay with that? What kind of an equation do I have left? Quadratic. Oh, lovely. How do I solve a quadratic? It's got to equal 0. So first things first, I'm going to subtract x squared from both sides to make it equal 0. And then to solve it, once it's equal to 0, I can either factor or use the quadratic formula. Now in this case, the leading coefficient is not 1. So the factoring, if it's possible, is going to be a little bit more complicated. Me personally, if the leading coefficient isn't 1, I'm just using the quadratic formula because I'm guaranteed to get an answer. And it's really no more time consuming than the long factoring is going to be to factor this. So I would recommend using the quadratic formula again. So I have negative b plus or minus b squared minus 4ac all over 2 times a. So that's negative of a negative is positive. Negative 5 squared is 25. 4 times 2 is 16. 25 minus 16 is 9. And the square root of 9 is just regular old 3. So 5 plus 3 is 8. Divided by 4 is 2. And then 5 minus 3 is 2. Divided by 4 is 1/2. But I'm not done. What do I still need to do? I need to check. So I'm going to take my answer back up to the original problem and check to make sure that I'm not getting, or that I'm always getting a positive value inside my logarithm. 3 times 2 minus 2. That's positive. 2 minus 1. Positive. 2. Positive. So that one checks out. Let's try the negative, or try the 1/2. 3 times 1/2 minus 2. Negative. I'm stopping right there. I know already that that's extraneous, and I'm done. This is the worst case scenario problem for solving logarithmic, is where you have this quadratic equation like nested inside of your logarithmic equation. You're seeing now why the quadratic equation is so solving these quadratic equations is so important, because a lot of these advanced functions, the solving process really boils down to just solving a quadratic at some point inside of the process, right? Whether it was a rational function, an exponential function, a logarithmic function, they all kind of turn into a quadratic at some point, or can anyways. They can. That was the last thing that I had for you guys to do today, or that I wanted to do with you guys today. The problems from what we did today are 99 through 130. That will not be due this weekend. What's due this weekend? 17 to 98. This will go into next week's problem set. Next class, we're going to do the homework quiz. That'll really just be on sections 1 and 2. So no logarithms on the homework quiz. After the homework quiz in the next class, we'll work on a Delta Math assignment. That'll be that whole day. And then the other day next week, we'll pick up with where we left off on the other class days. Sound okay? Okay. Good job, guys. I'm going to stop here.